All right, what's up everyone? Welcome to week 50 of Chill Kernel Hacking for Fun. Today we are working on Lab 5. This is pretty exciting. We're starting Lab 5 for the first time. In last week's stream on week 49, I finished up Lab 4. Lab 4 took several months to finish. It was a lot of topics. It was multi-core support. It was then implementing a fork system call with copy on write support in user space. And then in part C, we were doing IPC. So that was a big journey. And now we're starting the next thing, which is Lab 5. I'm going to do my usual test in the chat, just to make sure the chat widget is working today. And we will get into this. So okay, let me make sure I just have all my stuff set up. I have the Miro board set up over here. I will grab all this stuff. Ooh, did not get absolutely everything. I will just make a new zone for myself, call it Lab 5. And in Lab 5, we are starting, it's 2025, 112, week 50. Okay, I'm not seeing my test in the chat, so I'm going to do another one. Maybe that previous one was too early. Hello and welcome to anyone joining the stream. Thanks for being here on this fine Sunday. Music's going good. Okay, so what I need to do first is I need to merge in the code for Lab 5. I hope this goes smoothly. In the past, it has not gone smoothly, and it's been kind of painful, actually. Okay, it looks like my test 1 worked in the chat. So, chat widget is working. Let's slowly ease into it. What I need to do is I need to create a branch for Lab 5 and then merge my changes from Lab 4 into that. We can kind of see the last time I did this. Yeah. Hey Manit, are you doing the labs in order? In order? Is arbitrary order? Sorry, I subscribed recently. Haven't been following from the start. Well, welcome, first of all. Thanks for subscribing. I'm doing them in order. I'm doing pretty much everything just by the book, the way this class works. So I started with Lab 1 like about 1 year ago, and I've just been going through them in order. Yeah. Thanks for the question. So yeah, here last time you can see I was working on Lab 3 for quite some time, and also previously Lab 2 before that. And so, yeah, now it's time to do the same thing for Lab 4. Usually there's a couple problems that happen. Usually there are at least a few problems that happen. Lab 5, upstream Lab 5. So now I'm on my Lab 5 branch. I will also opt this into the filter. I'll clear out. No, I'll just leave it like this. Oh, okay, Lab 5. So now it's time to do the big scary command, merge Lab 4. And we have merge conflicts as expected. Hopefully this is not going to be too bad. So let's go through and fix them. I kind of like using fork for this actually. Let's start off with the make file. Or I like for getting an overview, but then let's just jump into VS Code directly. I did not even have it open to the OS yet. Let me do that. Okay. Nice clean slate for today. Let's find merge conflict. What is going on? Temporary merge range 2. Okay, it's this G stabs thing yet again. I think. Wow, this is like kind of a strange conflict marker. Head merge ancestors, some commit. Temporary merge branch 2. Okay, I think this is basically all about this stabs thing. So I think I cannot have this stabs. That caused build issues, I believe. So I'm going to resolve the conflict like that. Yeah, there were, right. Then Kimu got broken. I am a little bit disoriented because of this strange conflict marker that I'm not very familiar with. I think the main thing though is this Kimu opts thing needs to be like this. Oh, interesting. So there are actually some changes that upstream made. So now we're doing this FS thing. Oh, interesting. So what I think I need to do, I want to generally take the hunk from upstream, which is head, which has all this file system stuff. Okay, I think I can get. Okay, copy this here, replace this with this. This warn thing. Nah, I don't know what that is. I'm just gonna delete all the rest of this. This is my first attempt at resolving this merge conflict. Oh, there's another one too. It's interesting how it's like such an elaborate conflict marker with all this warn stuff everywhere. But I need this GDB prefix thing. I wonder if the warns are new. I'm just going to, I think I can just delete this whole thing. Okay, I believe that resolved the conflict for that file. Let's proceed to lab.mk. Okay, this is just junk. I don't think I need any of it. I'll call that resolved. Okay, now we're getting into the actual C files. env.c. Okay, this is not so bad. So I have my implementation of this function if this is the file server, give it IO privileges. I think it's just an extra comment I need to have here. Easy enough. init.c. Okay. User. I code. I see. Interesting. Is icode.c? Okay. So apparently we have this new user program. Oh, hey Rohith. Sorry if I'm mispronouncing your name. Great streams, Mark. Is it supporting your channel? I am having fun. Awesome. Thanks very much for being here. Thanks for the compliment. Yeah, appreciate the support. Yeah, I'll be super curious if anyone's interested in like systems programming or operating systems. Feel free to like talk a little bit more about what you're interested in. Yeah, I'd be super curious to know. Okay. So this is a new user program. So that just means I'm just going to accept the head. All that does is it controls which process is used as the init process to the first program that's executed. Yo, digitalized, what's up? How are you doing? I'm doing pretty well. another week back in the saddle. Resolving some merge conflicts. Took away my test one. Sorry, I had to take the test one off now. Yeah, because test 0 did not appear in the chat widget, so always appreciate you chiming in with the test. Okay, interesting. So this conflict, so they added this keyboard interrupt because interrupt has given up. That's interesting. I don't really know what that means. I'm just going to, apparently I had this run tests thing. I'm going to keep both. Okay. Is that it? And trap.c. Ooh. Trap dispatch. Oof. Okay. So in this merge conflict, it's possible that I moved a function around. I moved this trap dispatch function to the bottom of this file for some reason. It's always a little bit sketchy because then it produces these conflicts when I merge in the future labs, but okay, here, yeah, okay, that's a bit unfortunate. So now what I need to do is copy over this comment, basically. This is the comment they added this comment to their function, and then I moved the function around. So I need to add this comment to my, I need to paste it right here. I think that's all I need to do though. They just have this very plain trap dispatch. None of this is new. This comment is the only thing that's new. So I can delete this whole thing. And I will call that resolved. So git commit. I hope this works. Okay. So So I have, in theory, resolved the merge conflict. Does the kernel still compile? No. Oh. With a warning. Address of packed member. So what probably happened here is, so I'm using a newer tool chain than they did from this when they ran this class, and it's possible that GCC activated some different warnings in between the different versions. So that is a plausible explanation of what happened. Let's look at the code, spawn.c. That file is completely unfamiliar to me. And it's on line 110. Init stack. This is like user space library code, I think. And it's a warning because we are taking the address of a packed structure member. Right. May result in an unaligned pointer value. Yeah, so the resulting pointer might not be aligned. It might not be aligned on a word size, which is bad on some architectures. It's not valid. How do I fix that? What do I do? What if I don't care? Okay, maybe it's time to open up ChatGPT really quickly. Give me 1 second. Okay. So I'm just gonna Google this error actually. Ooh. Wow. So one way to solve this is I can remove the packed attribute, but I can't do that. Oh, so annoying. Okay, this is not even what I care about. Warning. Thankfully, a more warning message using GCC. And you can enable warnings and disable them with blah. So I think I need to go into my GNU make file. Flags. See, whoa. User C flags in particular. And what is it? It's like, okay. I Oops. Okay. So I attempted to disable that warning. Ooh, okay, I think I fixed that. What is this? Multiple definitions of symbols. Crazy. Curious about how you decided to move to Germany after studying in the US. I moved for work. Yeah, that's the reason I moved to Germany. I had this very particular job I wanted to work at. It's like company I wanted to work at, so that's why I moved. So we have a linker error. So anyway, first of all, that thing I did fixed the warning. Okay. Fix build error. libspawn.c takes the adder of a packed struct member, which yields a warning and thus error, since we disable this warning. Yeah. Unless there's a better way to do it. Unless there's a way to not do this in this way, but I don't really think so. We have this packed structure, and I don't understand the code context here, but we need, well, what? Yeah. This needs a pointer, unique pointer to, a pointer to an ESP. Which it does what it does, it write back to it, probably does. Yeah, it writes back to this. So I was thinking one other alternative would be to copy the value into a local and then pass the pointer there, but that doesn't work because we want to actually mutate this. Another way to fix it, I mean, yeah, we could have this function. Yeah, it writes, we allocate some local ESP thing, pass a pointer to it, it writes back to that, and then we later need to write that into the child trap frame. I am not going to bother. That's kind of annoying that Clang is warning about that. Oh, I think I need to update my compile commands.json to fix that though. Okay, I'm gonna start keeping track of this stuff. Update compile commands.json somehow with like this bear tool or something. Okay, that's not that important though. What's important is this other build error. So we are doing something here. Elf LD, blah, blah, blah. I'm just gonna search for this. Okay, what? How are you not finding this thing? Files to exclude, files to include. make frag. I think it's in this one. Okay, yeah. Should have known that this file system lab probably has a lot of build system stuff. I think it's this. Wow, what? This is crazy. Test.c. Oh, I think it's this line. Yes, I think it's this line that is failing. I'll take a screenshot of that. So hello to anyone joining, by the way. I am here trying to get my build system to work for working on file system support for the operating system, which is the precondition to working on lab 5 here. So, and I've run into a multiple definition error. Yeah, hopefully that shouldn't be too hard. So the question is, I could dive right in, but I just want to kind of understand a bit of what's happening here with this build a bit more. We are building like a binary, I suppose. Defaults. So the file system is special somehow, and just get a look at the source layout. Yeah, it's not even in the kernel. It's like in this thing called fs, which maybe makes sense because maybe some components are shared between user space and the kernel. This is a C file. So that's what I'm gathering. Although this thing looks like a driver, IDE. Port IO based, non-interrupt driven IDE driver code. So this is like a random driver. User apps, we have a user app. We have some text files to put in the file system. Okay, and then user apps. So previously we were building all of the user programs directly into the kernel, since we didn't have a file system. And now the ambition is to make a file system so we don't have to build the user programs into the kernel anymore. We can put them in the file system instead. Okay. So there's some kind of like file system program though that seems to be being created, but it's not a program. Well, I mean, this kind of makes it look like a program. From this file, I got the impression that it is a library, unless there's a main. I don't see a main. Yeah, I don't see a main. Yeah, they wrote a lot of code for me. Wow. So, okay, let's debug. Let's fix this build error. fs.h. Also, like, by the way, I feel like this is kind of like maybe a bit, seems a bit boring, but this is like fixing build errors can be a nice challenge, and it's also pretty real world. Like, it's not uncommon to be fixing build errors. Okay, 14. So we have a pointer to a super, and it is declared here in this header file. And this header file is presumably included by many clients. And this is presumably a mutable. Does this thing work? Yeah, this is a mutable global state. So what you do to fix this, like this is not the right way of doing this. The right way of doing this is to do an extern. I actually kind of forget the syntax for this, but the right way to do this is to do an extern in the header, and then have the declaration, or the declaration in exactly one C file, namely, let's just put it here in fs.c. So that's one thing, and I think it's super in bitmap, so probably just doing the same for this thing could also work. Let me just quickly check myself on that. I think there's at least one other use of extern. There's like several uses of extern in the code base, and they all kind of look like this: extern, blah, and if it's a pointer, you just do it. And so yeah, pretty sure that's the proper way to do it. Yeah, it always kind of surprised me how difficult it was to create global variables in C in a project with multiple translation units. Even global constants, you can't just create a global constant and assign it here, because it might work, but then you'll get copies of that for every single translation unit, which is probably not what you want. And you can work around that problem either with a define, which is a bit of like a hack. You lose type safety if you use a define for this. Or you can go this option with the extern and the definition in a separate C file, but that is really cumbersome to deal with. Or you can use C++, where you have like inline const expr global variables, and then it works nicely. So I'm gonna try the build again. I hope that worked. I think that fixed the that fixed the build error at least. Whoa, okay, that took a long time to run. So the build works. I'm gonna call that a win. I'm gonna call that a huge win. Dubs in the chat, please, if you don't mind. So we got the build working, which is a milestone. At least we're that far. We'll see if it runs in a little bit, but yes. Fix build, define globals using extern. Okay, so that built there. I'm going to take the moment to update my bear, my compile commands.json. I was pretty surprised at how easy this was last time. I don't have bear. Let me quickly bring this off to the side to see if I have my there. Huh, okay. Put the list. I thought I was in my, do I need to pip install it or something? Package, or do I need, this was annoying, okay. Or is it a brew? Okay, now my brew is like updating every single package on my system. Fetching bear. I hope it was called bear. I have no idea. Brew? It's called bear. Okay, good. I just did brew install bear. So I wonder what happened. I previously had it installed. Error. Bear make. Ooh. Okay, maybe this is harder than I thought. Okay, it's building. Bear your build command. And then it has a compile commands.json, which is empty. What? Bear make. Bear intercept help. Make, right? That's my build command, right? What version of bear am I using? 3. Okay. Yeah, that's a bit too bad. This like worked at some point, but clearly that didn't work again. Is there anything I need to do? My build works. That's with make. Okay, I am going to give up on that. It seems like it is not doing anything. Does it even create this file? It does. It creates this like tiny empty file. Okay, too bad. No compile commands for me. So let's take a let's go ahead and take a 20-second break to stand up and stretch. I'll be right back. All right. Okay, in this lab you will implement spawn, a library call that loads and runs on disk executables. So kind of like an exec but exec is a system call, and this is a library call. That's one difference, but both of them load and run on disk executables. You'll flesh out the kernel and the library operating system to run a shell on the console. These features need a file system. This lab introduces a simple read-write file system. Main component of this lab is the file system. Scan through the files to get a feel for what is new. There are also some new file system related source files in the user and lib directories. Should we take a quick tour through these? Let's do it. Okay, scan through the files in this directory. Let's take a tour of FS, the FS folder. Okay, bc.c. I want to guess that BC stands for block cache. Okay. As a general kind of orienting note, the way the architecture of like disk and storage stuff usually is like you have like your disk hardware. That's like, and then you have a disk driver. And then using the disk driver, you have some like block layer, which it's not like a file system. It just interfaces, and you can interact with devices on a block basis. And then using blocks, you can implement a file system. This is all in the kernel. And so the file system depends on the block layer. The block layer depends on a device driver. And then you have like the hardware. I'll make this like a dashed line. That is super skinny. And so when we're talking about block cache, I think when this thing is called the block cache or BC, I think it stands for, like, it's corresponding to this layer of the storage stack. Set page file, but this is running in user space? Wow. Interesting. This is a user space call. So it would appear that all of this runs in user space. Fault any disk block that is read into memory. And it involves user space page fault handling for some reason. They're talking about virtual memory and all this stuff. So it would kind of seem like we're going to map the disk into memory, sort of, something like that. So, okay, block cache, file system.c. Let's check out the header file first. We have a bunch of functions. Okay, so this header file corresponds to all of these C files. We have the declarations of the IDE disk driver functions. We have the declarations of the block cache functions, and we have the declarations of the actual file system functions, and apparently some other ones. And we have some constants. And then, okay, so in fs.c, we have some functions that do some file system stuff. Allocate blocks, check bitmap, file system structures, initialize the file system, blocking the file system, directory support, although this is actually already existing here. Skipping slashes. Okay, but a bunch of functions. This format. This is interesting because I think there are some tools in here that run on the actual build host, I think, like my dev machine. This might be one of them. So format a disk, like create a disk image, probably. Write file. Finished or finished disk IDE. So this is the driver functions, and apparently you can interact with some kind of like legacy disk protocol, the IDE disk protocol, using port IO. And they kindly provide the driver for us. And then there are some random data files that get included in the disk image. Then we have this thing called the file system server, which is interesting. Serves IPC requests from other environments. Okay, so apparently you have some process running on the OS, and it's the file system server, and if a process wants to do disk stuff, it talks to this server, apparently. Serve init, allocate an open file. Okay, I don't really know what's going on here, but like it's some kind of server. So that's a user space program probably that runs in the OS. It doesn't out what, but I'm pretty sure this runs in user space. Okay, test. Let's see. This is like some test file, I guess, which runs in the kernel. Test shell. Okay, there's like some script for testing the shell that we're going to write. So that was a bit of a tour through the FS directory. And then, okay, we can check out the code in the user and lib directories. Let's check out lib. So fd.c. Oh no, or wait. Is all of my like jump to definition and stuff broken now? Wait, trap. What? I need to find something. Ooh. Okay. It seems like some of that stuff might be broken. No, that's working, but ouch. Okay, it's probably because of it's probably because of that compile commands JSON. I am going to disable my ClangD plugin and re-enable my C++ plugin, maybe. Enable. So now that's starting up. Okay, so that seems to be working a bit again. ClangD's off. Okay. Oh well, I guess I'm not using ClangD anymore. Okay, back here. So fd.c, so file descriptors. There's like some kind of file descriptor interface here, apparently. Some like disk interfaces and lib.h. Okay, this is the public header for all of user space. The user space support library. It's roughly a link. It's roughly libc. Okay. And here's our new fd functions. Okay. File.c. So apparently this thing is used by that file system server. Maybe. With some global data or something. Okay, so this is the driver for on disk file type implemented as a file system IPC client. Okay, don't know what that is. Driver for the, so apparently there's like these different types of files. Console input output file type. I guess the file descriptors can correspond to different things. And there are these implementations that are kind of behind the file descriptor abstraction. Oh, you should run ping pong, primes, and fork tree from lab 4 again after merging in lab 5. I hope that still works. Okay. Run primes. It's very difficult to tell if this is even working. Ooh. Ooh, that's bad. Oh. So, once again, it would seem as if the kernel is not even booting at all, which is crazy. We're not even reaching the bootloader. Yeah, something is going horribly wrong with even booting the OS, which is what happened, I think, probably last time, and most times I go to a new lab, it breaks the boot process. So yeah, I think we will need to debug that. That is so shitty. Wow. Okay. Just in case. I think we're going to see this with absolutely everything. Okay. Well, this has now turned into kernel debugging, hardcore kernel debugging. I have a guess, because this is not the first time this has happened to me. So I have a small guess at what could be the case, because I think this kind of exact thing happened one other time. I am going to dump the load commands of the kernel. Okay, that actually looks correct. Last time there was this very strange bug where the phys adder field was wrong. It was like way too high. But this looks right. Dang, okay. So what can I do? Okay, what I want to kind of do is yeah, this merge is going to kind of suck because it's like in the wrong direction. It's showing all the code that I added, but I want the opposite basically. So what's going on here? Drive. Okay, I have another guess. Well, okay, so there's a couple things that it also says you'll need to comment out the code here because this thing tries to do some IO which JOS does not allow yet. Similarly, comment out this thing. If your lab 4 code doesn't contain any bugs, the test cases should run fine. Don't proceed until they work. Don't forget to uncomment out. Okay. Make sure that okay. So, okay, before we can continue, we need to make this work again, as usual, which always kind of sucks. So my first debugging guess would be to remove this line and do not pass this other drive. And it still is crashing. Okay. So I kind of feel the instinct to do a reverse merge in the other direction, which will show me the files that were effectively merged into my branch, which frankly I think I should be doing it that way anyway, rather than merging into their branch. But I don't know if there's an easy way to browse through this. This changed. This changed. This changed. This changed. That's no longer there. So now we have just all the code that I wrote so far being added. The boot, there's no boot files. What about this? Tests.c. Yeah, this is going to be basically all the code I've ever written for this OS in this diff, which is going to be so noisy. All right, yeah, maybe it's time to do a reverse merge in 20 seconds. It is way too hard to see what is going on. So here's what I'm going to do. I'm going to check back out. Oh, 5 changes. Okay, I don't need these. I'm going to discard. I'm going to check back out here to lab 4. I'm going to rename this to dev. where my dev, I think there's already a master branch, and yeah, like I don't want to compete with that. And then I'm going to git merge lab 5. Did that not have any conflicts? What just happened? Oh, it just fast forwarded me. That's not what I want. Okay, set add hard lab 4. Let's try that one more time. What I want to do, git merge no ff lab 5. This should conflict. Didn't conflict. Where's dev? Ugh. That's also not what I wanted. Reset our lab 4. Am I being like stupid right now? Ah, I gotta say upstream git merge no ff upstream lab 5. Otherwise it thinks it's using this local one. Now we get our conflicts back. We will unfortunately have to resolve them, but since I already did this once, it shouldn't be that bad. I just need to move this. Or yeah, we just need to get rid of all this stuff. Similarly here, this direction is way nicer to merge because we can just keep our head changes which were working. And delete all the stuff we don't need, except we do technically need. I hope the Kimu order is not so important. And similarly, we can just delete all this stuff. We're not losing anything important. Okay, good. One down. Let's speed run this lab.make. Oops. Easy. And then env.c. Also not so bad, I think. It's just this. I think this goes up here. Or maybe, actually, maybe. Why can I not undo? Maybe actually it was meant to be at the bottom. I'm gonna keep at the bottom. I don't know yet. Okay. Moving on to init.c. With this whole big thing, which we actually don't want. We want to take this, and likewise, we're going to take this. And it's unfortunate that we're getting that warning, but whatever. Okay. And trap.c was the last one, and all I needed to do, what I wanted to do was copy this comment. This thing is annoying. Okay. I don't have Clang D running. That's okay. This goes here. All right, I'm gonna reload my window to to hopefully make that warning go away. Okay, so now this thing goes here after the lab 4 stuff. Yes, okay. Okay, word. So that was my attempt to speed run resolving the merge conflicts. What does lazy git have to say? Okay. Run tracking branch. Mate. And okay, then I need to. This is not going to build for the same reason, so I need to cherry pick. It's getting a little bit yucky. Wow. So now I need to cherry pick my 2 fixes. Ooh. Copy and then paste. Cherry pick. Okay, so now I've cherry picked. I've merged in the code into dev. I've cherry picked the 2 fixes, which should hopefully get us back into a building state. Yes, we're building again. And we're probably still not booting, but at least we have a better diff to look at. Right. Okay. Okay, now let's look at this diff and see if there's anything interesting. So I'm going to hide lab 5. We don't want it anymore, so don't need this. Dev. Now that we have, so I think now that we've merged this in the correct direction, we will be able to more clearly see what the changes have been since it was working last time. And in particular, I am interested in why it could have possibly, what could have broken it. Because this is adding a lot of new stuff, but it's not changing the old stuff. So my first impression is to comment out a lot of this stuff. I'm going to make file, for example, 152. What if we get rid of this? What if we get rid of this? What if we just do that? Does that help in any way? No. It doesn't seem to. Well, either way, I think I'm going to leave that commented out because that's just adding complexity. So that's the make file. What about the kernel? So we're adding a bunch of binary files. Init start fs, keyboard interrupts. But really, the craziest thing is that the kernel does not even, nothing at all runs. The last time this happened, it was because of strange side effects. And so a lot of global buffers were used, which caused a side effect with the linker. And that caused the bootloader to load the kernel wrong. And everything crashed. I think it might be time to GDB. Let's enter GDB. Or what does make Kimu do? Just a simple make Kimu. That also probably doesn't do anything. Yeah. Yes, okay. Yeah, time to debug. Okay, oops. Deleting my breakpoints. Okay, let's start from a very simple place. And this will be good if you're new to this stream. You'll get to see a little bit about the boot process, which I haven't worked on in a very long time. I'm going to break on the main function on boot main. Dang. How do I do that again? Boot main. What binary? Boot dot o. Yes. Break boot main. No. Or break file. It's main.o probably. Main.o. Yes. Yes. File boot. Ooh. Break boot main. Yes. Ooh. Okay. So that didn't work. This is really wild. So maybe I will just try to do this. Okay. It's been a little bit of time since I have debugged this like crazy low level stuff. This is pretty much just straight up. Okay, here we are. We are breaking on the first instruction of the bootloader. At least we got this far. Call boot main. Okay, break hex 7D19. So, oh. Okay, yeah, no, that's correct. So now I believe we're in the bootloader. It is kind of frustrating that we don't have symbols. Let's fix that. What? Makefile. Main dot. So boot main is created here. It's main.o. Boot obj is unlinked. Is it called boot? It's like this. It's this binary called boot, which then gets like taken apart via obj dump and obj copy. I believe. Or no, it's boot thing. We create, I don't know, boot.out or something. It's like boot.out, which is an elf. Yeah. This final boot thing. It's still a bit of a mystery, to be honest, exactly how that works. I think it's because of this sign appeal, which makes this thing which is what causes this thing to say DOS boot sector. Because this is the thing that puts like the special bytes in there, I believe. Yeah, this is crazy though. At one point I was able to debug the bootloader. No, I think I need, yeah, I think boot.out is what I need. File, boot.out. Yes, yes. Yeah, the boot main. So, right, now, okay, now I have symbols. And I can debug this in kind of a more sane way. So, yeah. So one, like, first thing we can ask is, do we even get to the kernel? Which, I will just make some space over here. Obj kernel.asm. And what is this thing? Entry? Just adds. This address. However, wait a sec. That's linked with the kernel virtual addresses. It's going to be much lower. I think it's going to be just this 1000 thing, actually. We got there. So we are here in the I just want to, where, do I have a GDB in it? Oh, oops. Yes. Okay. These things were useful to, these addresses will be useful to keep around. So this is the start address of kernel, but maybe I'll put this on a separate line. So that, the fact that we got to this breakpoint tells us that the kernel is getting code execution, but we are unfortunately crashing in the kernel before we get anywhere every time. So, yeah. Okay, that is at least some information. Let's set this thing to the kernel. Okay. What I want to do now is, I mean, single stepping is not really that hard actually from here. So we enable paging. We jump into, jump into high memory, relocate the kernel. And we even enter C code. This is interesting and good news. Maybe I could have done this earlier. So now I even have C code. So okay. So the kernel is crashing probably somewhere here. This is kind of suspicious. I'm like not sure what this keyword interrupt thing is. Yeah. Let's just Next. Oh, that was it. That was it. Here's the restart. That's what it looks like when the kernel crashes. Kimu resets everything and converts the CPU back into like 80, 86, 16-bit mode. Very interesting. All right, 20-second break. Be right back. Okay. So it would seem as if I wonder what happens if I do this. W. Oh, the console has not been initted yet. So that indicates that, yeah, something like that is okay. If I panic right here, what happens? I think it's gonna crash. Yeah. Yeah, okay. So that is pretty clear. There is something wrong with this, the memset of the E data. Linker. It's always the linker. Always something wrong with the linker. Okay, so what's up with this? So first off, if I comment this out and then do the panic init, this should say init with the panic, I think. Actually, no, we haven't initialized the console. So if we move this down, now we can start to panic with a message. There we go. And this is happening like a bunch somehow. But now we... Actually, it's kind of funny that panicking didn't work and triggered this like kind of recursive weird thing. Enabled interrupts. 1, 2. Okay, whatever. Anyway, yeah, it's quite clear. The problem is this memset, and it's probably accessing invalid data somewhere. LD, kernel LD. This E data thing comes from here. What is eData? That's a question we should find out the answer to. Okay. Read 86. Read elf. Kernel. Wait, where am I? Okay. eData. This is eData. So what often happens with these lab updates, also it's like so small. Should I make everything way smaller? Yeah, maybe relatively speaking, yeah, these are huge. Okay. Maybe this a bit more size appropriate. So in this very early part of the boot process, only one page directory is mapped. So it is possible that the kernel grew a lot again, and that is somehow causing problems. I am just curious, what happens if we all right, well, first I'm just gonna temporarily commit this. What happens if we go back to lab 4 and make clean make? And then what happens if we try this again? Look at edata. Up 5 edata. It's bigger. It is bigger. What do we do? Again, going back to the diff. So we just see that a lot of stuff is here now. Ultimately, what goes into the kernel is determined by this. So we're adding a lot more data to the kernel. I don't know why these are in separate groups, but we're basically ballooning the size of the kernel quite significantly. So I have another thing to try. So we previously observed that, so this is going to crash because we crash on the memset. I'm gonna put the panic here, which doesn't really work, but we see some like W's on the screen. This is going to crash because it happens after the memset. Whoa. But no, this is like from booting or something. I think it was still crashing. If I take this away, we get different behavior. Kind of. We sort of get the behavior that means it didn't crash. Right. Now I'm going to add this back, and I'm also going to remove a bunch of these things. Yeah, we are, oh, wait a sec. Oops, that's why. I need to switch back to dev. Okay, now we're back at dev. Make clean, make. What happened? Oh, because I commented out this thing. I'll revert this quickly. Apparently that's needed to build the kernel. Okay, so now the kernel builds, and what I've done is this. So the kernel should crash, right? That's what we expect. It doesn't print anything, and it's just like looping here like crazy. My experiment is going to be to not do this part. We are just not going to balloon the size of the kernel with all these extra user programs, and I wonder what happens in that case. Yes, that's the thing. If we don't balloon the kernel with all this extra data, we don't get the crash. So again, it's kind of similar to the crash I was observing last time. Like by last time, I mean like many months ago, where merging in the lab code changed the size of the kernel, which impacted other things, and maybe made the kernel grow too big or something weird like that. So yeah, that is interesting. Last time it wasn't even able to, like last time the kernel crashed very early on because parts of it didn't get loaded into memory properly. This time that is kind of not the case. It's still able to get into the C code and stuff. It's just crashing on this E data thing. And what does the code do? We memset from E data to end minus E data. What's end? I think that's actually the very interesting question here. Oh, this is annoying. End here on the new kernel is this thing. Wait, does that make sense? It is. It kind of looks like it's smaller. What the hell? Okay. Time to unknowingly. Okay. I'm just going to. Oops. Fix. Temp. Yeah, I could squash stuff. For some reason, I just don't do that. I just make these temporary commits. So now we're back on lab 4. And this is what it looks like over here. Right, so this is EF023, F027. So that kind of makes sense, right? End is bigger than E data. End is like the end of the kernel. This is bizarre. It is looking like E data is after end. And if we subtract E data, end minus E data, we're going to get a negative number, I think. Which is crazy. I think that's like how this works. So here's what I'm going to do. I'm going to int 64. I don't even know if I need that, but I'm going to do int n minus e data. Int diff. If diff is less than 0 while 1. Because like we can't even print anything at this point, so all I can do is like infinite loop. And dev. Okay, can I just here? Okay. So now what I think is going to happen, it's still going to like block, but we're like not going to we're not going to see these screen flickers that we were seeing before. Or we even panic. Wait a sec, what? Oh, we are panicking because I commented out this thing. So let's like revert the temp fix. What's up, Carlos? Why you decided to move to Germany after studying in the US? Oh yeah, Minute asked that earlier. It was very simple. It was because I had a specific job I wanted to work for in Germany. Yeah, so now we're running the kernel, and now it's blocked, but I think we should not see any green flickers. We actually do though, which makes me feel okay. Let's get into here. Break in I386 init, nice and comfy. We're in there. We've got diff. What's diff? Diff is optimized out, obviously. Okay, so diff was not less than 0. What? PE data, pend. Okay. That is so. Did I do something wrong? Okay, maybe I wait, was I like absolutely E. Okay. This has changed now, but wait, what? Do you do low-level development like this in your day job? No, I don't, unfortunately. Well, fortunately or unfortunately, but no, I don't. I do C++, like normal programming, not like low-level kernel development. If I did this in my day job, there's a chance I might not be so inspired to do this in my free time. Yeah, but it would be kind of cool to do stuff like this at some point in my day job. So what happened? So okay, I haven't really changed that much. And these actually look kind of sensical. It's like weird and wrong. So that actually looks right. So maybe I will print out maybe I will make some variables for these things. So no edata. Always like, yeah. And memset from edata. How big is our kernel at this point? 3.1 megabytes, which this should fit, should like completely fit still. But yeah, but wait, okay, I'm getting a little bit confused between all these. So here we're stopped in the debugger, right? Oh, fatal error. Whoa. Okay. So we have the temp fix now. Okay, I'm getting kind of confused. I will be right back. Okay. So let me just clean things up a little bit. So right, this is crashing and stuff on this thing. If I panic here, it doesn't. We see some weird letters on the terminal, right? Okay. My only theory, like clearly a bad memory access is happening somewhere here. Just to test my little assert thing here, I'm going to change this. So now we should definitely see the while loop take effect, I think. And we'll see what that looks like. Right, we get this nice crystal clean like screen, which means it hit the infinite loop and it's not like triggering the screen again. Okay, so now that we know this like assert kind of thing is working, what next? So we know the kernel has grown in size by a fairly substantial amount. It's now 3 megabytes. This should be totally fine though, because the kernel is loaded. Oh, the kernel is loaded 1 megabyte. kernel is loaded at 1 megabyte away from 0, and then it grows up. And our mapping, this kern base maps at 0, I think. We can look at our entry page directory. We map kern base wait a sec, what? Yeah, we map kern base to point at 0 to 4 megabytes. So that kind of explains what's happening. The kernel actually grew out of the 4 megabyte region. It's kind of funny. Yeah, so the way things work is the kernel is loaded at 1 megabyte in physical memory. And we kind of boot and stuff. As soon as we can, we switch to the version 1 of our page tables, which are very simple. It's just we map 0 to 4 megabytes to the same thing. It's an identity mapping. And we also map these high MM addresses of kern base, but at the start it's just 4 megabytes. And that maps also directly to this low 4 megabyte region. And what has happened is that the kernel over time has gotten a little bit big. It's gotten so big that it's kind of overflowed the 4 megabyte region because we have 1 megabyte of padding, and the kernel is now 3.1 megabytes, which is just 0.1 megabytes over the 4 megabyte limit. And that's going to crash here because we're going to try, the mem set is going to try to write to the end of the kernel, but that last 0.1 megabytes is going to exceed the page directory, and it's going to hit unmapped, an unmapped area actually. So that actually informs me of the way I need to fix this, which is kind of interesting. I need to actually modify the entry level page directory. And I need to do something like this. So, wait, no, that's completely wrong. I need to do here, kern base. It's not kern base, it's kern base plus page size. I wonder if I can, kern base plus, no, page, it's kern base plus the size of a surely I have a macro for this or something. PT size, right? No, I mean yes, PT size. It's page directory size, bytes mapped by a page, yeah, plus PT size. No, but that's plus PT size. Kern base plus PT size is going to map to oh, wait a sec. So does that mean I need a new thing here? Ooh. This is that weird thing. I need thing. So I need another page directory and another page table that is annoying. Why? Yeah. Okay, so there's a few solutions here. My problem. Okay. So I see. Kernel is now 3.1 megabytes. This overflows the 4 megabyte region. We map in the entry page tables. We crash in memset e data when we try to write past the end of the page directory. There's a few things we can do. Basically, option number 1, we can make the kernel smaller. Don't change any page tables. Option 2, we can keep the kernel big. Change page tables. These are the two options. One, for example, one way of making the kernel smaller is by include less user programs embedded in it. That is, yeah, one way to do this. Number 2, keep the kernel big, change the page tables would be the second way. And so how do we change the page tables? Change at compile time, add extra page dir entry and page table. The alternative is to do it at runtime, which we currently are not really doing. We are like oddly constructing this at compile time. And so I guess my goal there would be I would make another page directory mapping that maps another 4 megabytes of memory, probably. I kind of want to do that. I feel like constraining the kernel to be super small is like a bit of like a hack, and we will run into this problem in the future when we keep adding more and more stuff to the kernel. So I think it's probably worth investing into this extra page table, and it's also kind of a fun experiment. So I need to add another page directory entry, but then I need to have another one of these. It's kind of funny. Yeah, this is like a whole... What's up, Christian? What's that on your wall? It's a calendar. Just a calendar of the year. Okay, so it's pretty clear how to add So how does this work? So these are this is the compile time created entry page directory. It has just some entries that that's kind of specify from which page directory entry to fill out. And we're basically just saying the first page directory entry and the one that corresponds to current base, and fill them with an entry that points to entry page table minus current base. Wait, yeah, what is that? Page table. So this points to the page table, basically. Oh, sorry, I guess I missed that question. Hana Soga Pranav. Yeah, it can be intimidating. I have a resources website, which I compiled for questions like this. Yeah, I think it's kind of like a stepping stone, one thing after the other. Kernel programming, I would say it's kind of far, it's like at least intermediate in that journey. Depends on where you're starting. But I have this resource called pwn.college. I really like, it's a bit more cybersecurity focused, but that's a lot of very practical exercises to work your way towards a lot of these skills. I'm a little bit puzzled actually what's going on here with this. I see. So we need to convert this to a physical address. That's why. Entry page table is linked with a virtual address, so it's in high memory. And we need to compensate for that by subtracting kern base to convert that to a physical address. So next, so basically what I need to do is generate another one of these, which is doable. And it looks like it's just this number. So I might just use a Python script for this. Yes. Bim. Okay. gen.py. Oops, right. gen.py. And this is going to be pretty simple, I think. Right, so there are what is this, 1020? Is that 1024? No. Yeah, okay, that is. So there are hex 400 these entries. So ours needs to begin from hex 400 and go up, I believe. I'm going to try this. So I might not even need, okay, whatever. For, how do you even do, it's been such a long time since I've coded Python. Range hex 400 to hex 400 plus hex 400 in increments of hex 100, hex 1000. But this is all super weird. But so actually I need 3 more zeros. In increments of hex 1000, print. Then I want to print out a line, not printf. Wow, it has been so, I am like blanking on how to even do string formatting. or I could just probably use one of these, I guess. So I need to generate a bunch of lines that look like 1, 2, 1. It's a tab, I think. So it's a tab. Yeah, no problem, Hanasoge. It's a tab, and then I think that's how you make it hex, and then PTE P, PTE W. Okay, should we try running this program? Python 3 gen. Right, that's what it looks like. And we've generated our page tables that map the second 4 megabytes of memory. And now I'm going to paste them in here. This is like a good exercise. Okay, page entry, page table 2. And then this one is going to be page table 2 minus current base. And with that, I think I've actually fixed my page tables. And I think the kernel might actually boot now. Oh, fuck. I forgot the hex, OX, Jesus. So that was close, damn. What do I do? What's the fastest way for me to... No, shit. I'm coding, even though there's this palm tree. There we go. I think I just added the hex in front of all of them with some dim stuff. I'm gonna kill the palm tree. I think it's time, so I just added the hex. And I don't know, this will be a bit of a Hail Mary. I think that works. Oh, fuck. Oh, so I need to, I need this. Oh, oops. I need to forward declare it. Ooh. Subscripted values neither array nor pointer nor vector. 29. Shit. Subscripted value is neither array nor pointer nor vector. What do you mean? Oh. Okay, I see. I think I forgot the comma. Okay. Let's try it again. Pwn.college? Christian? Pwn.college works for me. Got it right here. And we're panicking on init. I think that's, yeah, exactly what we want. Okay, cool. I think that fixed it, guys. I think that actually fixed it. So I'm going to remove the panic. And the kernel boots. Yeah, it crashes with the file system stuff, but the kernel is successfully recovered and it boots again. Wild. Well, cool. I am glad I could fix my kernel. That was actually kind of satisfying. Okay, I'm gonna remove this stuff. And yeah, that was cool. So yeah, basically, yeah, to summarize, I had a kernel. It like worked. You could like build it, load it into memory, run it. Then I added a lot more code to it because I added all this new code for the lab 5. It's like this new lab in this course. it added a lot of stuff to the kernel and made the kernel grow in size. It made the kernel grow so much that it overflowed the region of memory we had mapped for it. The next step is, one of the first thing the kernel does is it zeroes out a large portion of itself as part of the elf loading process, which requires doing like a really big write, like writing zeros. This process, because the kernel got so big and overflowed this like region that was mapped, this process of writing zeros also overflowed and triggered an invalid memory access. In order to fix this, I ended up expanding the range of memory that we map and can safely access. So previously, we only mapped 4 megabytes, and that was enough for the kernel. Now the kernel is 3.1 megabytes. When you add that to the 1 megabyte of padding that we reserve at the start, that overflows 4 megabytes. So what I've done is I've allocated an extra 4 megabytes of space for the kernel. And now we can safely do that big mem set of zeros all the way to the end and stay within the range that we have reserved. And our kernel runs and it like kind of crashes on some weird stuff, but now we are going. I will shortly head out, but I wanna just quickly follow up on these things. So you need to comment this thing, and it tells us all the ways it expects our kernel to crash. So fs, I'm going to comment this out. Exit.c, what's it, close all? I'm going to comment that out. Is that it? Okay. Now I'm going to run like ping pong, for example, which was one of the programs we had previously, and pray that it works. And it works. This is one of the test programs where it uses the IPC features to send numbers back and forth from a process, and I can also run the primes program. Whoa. So, okay, there's a new line. The new line missing somewhere here. There's a new line missing here. How did that happen? Yeah, that looks right to me. When primes finishes it exhausts the amount of processes available on the system. There we go. Okay. So primes is running, and yeah, it's like computing prime numbers or something. I don't know. Yes. So I think that all totally looks good. So all right, so I'm gonna end the stream by yeah, I'm just going to commit this map additional 4 megabytes in entry page dir 2 with lab 5. The kernel grew to 3.1 megabytes, which combined with 1 megabyte of padding overflows the 4 megabyte region mapped for it in entry page dir. Allocate a second page dir to accommodate for this. So now we're safe until the kernel grows until 8 megabytes. Yeah. Great. All right, y'all. That's going to be it for today. Thanks so much for joining me. And if you want, you can feel free to join my Discord server, which is a little bit inactive, but feel free to come and hang out. You can ask me questions if you want there. We can talk more. I do this every week. Please subscribe to my channel if you enjoyed what you're seeing. And yeah, I'll be back here next week, and it's very exciting because I'm very close to reaching 1 year of weekly streaming. This week was week 50, next week 51, and the week after will be week 52. So that's it for me. Have a nice week, and I'll see you next time. Bye. Bye, Christian.